So I just finished putting together Monday's quiz, and I mentioned that because I realized that I'm throwing a lot of units at you, and it's really important that you understand each one separately because the units matter not only for getting a point if the AP rubric for a certain free response question has units, but they also matter because units can be a clue into what a number is. So for example, if you have a Newton, you know it's a force. And so on the upcoming quiz on Monday, there are several questions, like 2 or 3 out of the maybe 10 on the quiz, that actually just say, if I multiply these two things together, what unit should I get out of them? Or what's the appropriate unit for this? So you need to know units really well because obviously those are going to be AP level questions, so I'll find or have found tricky ways to ask them. Newtons apply to forces, and a Newton is a kilogram meter per second squared, and that comes out of the fact that force is mass times acceleration, so mass times acceleration. This thing right here is a Newton in what we call base units, so kilogram meters and seconds are metric base units, or not base units, but basic units. That's the better word for them, basic units. Kilogram meter per second squared. That's a Newton. You need to know that. There might be a question that says, which of these is the same as a Newton? And it'll be like seconds times meters cubed, kilograms times meters over hours, or kilogram meters per second squared. And the answer is kilogram meters per second squared. So a Newton is a force, and the basic units inside a Newton are kilogram meters per second squared. Now a joule is, as you learned from work, just a force times a distance. And so if we took kilogram meters per second squared and multiplied that by a distance in meters, we would get kilogram meters squared per second squared. And that are the basic units inside of a joule, kilogram meters squared per second squared. Because a joule is a force times a distance, and a joule is either work, which is just change in kinetic energy, or a joule is also energy. So if you see a joule on something, you'll know it either goes in as work or some type of energy. Just like if you see a Newton on something, you know it goes in as a force. And then finally, a watt is what you get when you do power equals work over time. And we just found out the basic units for work are joules, units for time are seconds, or sorry, the units for work are joules, units for time are seconds. And then the basic units inside of a joule are kilogram meters squared per second squared, divided by seconds. And the basic units of a watt are therefore kilogram meters squared per seconds cubed. Okay? And a watt is always a power. So those units help you know what they are. So if you see newtons on something, you know it's a force. Joules on something, you know it's a work or an energy. Watts on something, you know it's a power. Also, you need to know what their units are inside them. So if you're ever confused about, wait, I need to get a newton that's kilogram meters per second squared, you can kind of see what things need to get multiplied together in order to get kilogram meters per second squared. And it's kind of from the first day in AP Physics where you did all the dimensional analysis stuff. All right, it's a lot of information about units. If you need to watch this part again, I encourage it. And that's all. Have a good night.